In this video, we are going to discuss about the dynamic circuits. So on completion of this dynamic circuits, students will be able to explain the logical families of the dynamic circuits and the pitfalls of the circuits. So in dynamic circuits, this dynamic circuits relies on the signal values of capacitance of high impedance circuit nodes. So in this section you can see the alternate logic style called this dynamic logic. So here the basic construction of n-type dynamic logic gate as well as the p-type logic gate is given. So if you see the nMOS side, it is 2 and pMOS value is 1. So 1 in the case it is resemble as weaker, and when this clock value we are giving as 0, this output value out is pre-charged to VDD by the PMOS transistor. During this time there is an evaluation in the NMOS transistor and it is kept as off. So completely the static power is assumed to the pre-charge mode, and also the supplies both the pull up and pull down network to get the pre-charged. So when this clock value tends to 1, this pre-charge transistor will be completely off and this evaluation transistor will turn on. The output which you are continuously discharging on the input values, for example if you are giving a 2 in the NMOS transistor and 1 in the PMOS transistor, is completely discharged based on the input values and the pull down topology. So if the inputs are such as the pull down network context, and now this low resistance path exists between the out and the ground. And here if you consider the logic circuits, that is dynamic logic circuits, here also this n-type dynamic gate is charged to VDD and the output inverter is also set to the 0. So during the evaluation time, this dynamic gate continuously discharges and the output inverter makes this conditional value from, it changes from 0 to 1. So here you can see the DCVSPG encoder. So here this new circuit configuration, that is the differential cascade voltage switch with the pass transistor logic tree, is presented here. In this circuit we can see the pass gate logic tree, that is replace the NMOS logic gate in the conventional DCVS circuit. This will eliminate the floating node problem. Also this is the CMOS, this is somewhat related to the CMOS circuit technique, that is having the advantages of you can use in the over conventional NAND or NOR logic in terms of circuit delay, layout density, power dissipation, and also logic flexibility. When we see the advantages of this DCV, this DCV contains several benefits over the discrete parts, that is it contains smoother operation, reduced shock and noise, lower energy consumption, and also even a improved performance. So when comparing with the cascade and cascode, these transistors in the cascade amplifiers are connected in the series, but in cascode amplifiers they are connected in the parallel. While seeing the importance of this DCV, this allows the fluids or gas to flow in the different paths, and also which provide the passageway from one component to another component. So this occurs the delivery from the one state to another state, and also it contains power reduction. So from this DCVs, this can be used in the industries for the passage fluid, and also it is very difficult to adjust manually every time. So it controls the fluid control in the changing position. It can change from one point to another. So from PMOS it is connected to the output of the next transistor, and the NMOS it is connected to the output of the other transistor. So this determines the DCVSPG encoder. And here we can see about the double pass transistor logic. So double pass transistor logic is used for improving the circuit importance, that is for improving the circuit performance at the low voltage, and also this is very symmetrical arrangement. You can see the symmetrical arrangement, also you can see the double transition characteristics here. So this arrangement improve the gate speed with an increasing and input capacitances. So mainly this double transistor is mainly used for improving the circuit performance, as well as the it can used in the very reduced voltage. For this arrangement, this based on this arrangement, this improves the gate speed and it's improving performance. And also this has two inputs. Here you can see the two inputs, and also it considers the complements of the inputs. So totally it has four inputs. So here we don't use inverters for complementing the inputs, because if we use the inverters, the transistor count will increase the power dissipation and also increases the total inputs present in the gates. So that if the operation is same as the CMOS gate means, then the inputs in the inputs and the outputs will be same. In this way we can use the two PMOS and the two NMOS transistor and to design the double pass transistor logic XOR gate. So you can see the NAND gate and the XOR gate. Next one is circuit pitfalls. So circuit pitfalls is nothing but the main thing is to avoid the bad circuit design. So here it find out it main thing, it find out the detects anything present in the bad anything is present in bad circuits, and also it find out what are the pitfalls present in the real chips. So based on this we can find out the reliability of the circuit. If you are consider, for example, if you are considering the 2:1 multiplexer means this works when D is 0 but not in the 1, and also it falls at the low VDD. So here the basic things which we are noticing are threshold drops, ratio features, leakage, charge sharing, power supply noise, coupling, minority carrier injection, backgate coupling, diffusion input noise negativity, race conditions, delay matching, metastability, hotspots, soft errors, process sensitivity. So based on these things, based on the 15 things, the circuit pitfalls are identified, and it will be identify the bad circuits which are present in the circuits, and finally it produces the reliability of the circuits. And major thing problems which occurs here is the leakage. So to avoid this leakage, we are charging on the node, and eventually this subthreshold leakage may disturb the charge. Finally it periodically refreshes the node, and also it requires the fast process. So based on this the leakages can be avoided. And also if you are holding the dynamic node as a charge node means, then the subthreshold leakage may disturb the other charges. So this is one of the major problems. So this leakage problem should be avoided, and hence this reliability should be sustained in the circuit. So mainly these 15 things are mainly noticed to avoid the leakage problems, threshold drops, and also the charging problems, noise problems, and small noise margins which are present in the circuits, or if the gates are very smaller, or if it is producing delay. So these are the symptoms are avoided using this circuit pitfalls. The quiz questions on this logic families is: which circuit needs to address the leakage and noise margin in the circuit? Thank you.